All right, so I'm going to help you guys finish dividing radicals. So yesterday we talked about the quotient rule of radicals, and we talked about the steps in dividing radicals. So you're going to first divide coefficients, then use the quotient rule, and then simplify the resulting radicals. So in all classes yesterday, we finished numbers 1 and 2, and we did number 3 as well, but I'm going to go over number 3 really quickly just so you guys can remember that when you have a variable raised to an exponent being divided by another variable raised to an exponent, you're going to be using the quotient rule of exponents. So this is going to turn into, this expression is going to turn into the square root of x to the third y to the ninth divided by x squared y to the fifth, right? And the quotient rule of exponents tells us that if you have a variable raised to an exponent divided by the same variable raised to an exponent, you're going to subtract the exponents, right? So I have x raised to the third power being divided by x raised to the second power. So my answer would be the variable, and the exponent would be what I get when I subtract the exponents, right? So 3 minus 2 is 1. So this would be x to the first power. And then I have y raised to the ninth power divided by y raised to the fifth power. So again, we're going to subtract the exponents. So my answer is going to be y, and 9 minus 5 is 4, so y to the fourth power. Now to simplify this expression, this radical right here, you can take the square root of y to the fourth power, right? When you're taking the square root of a variable raised to an exponent, or the third root or the fourth root or the nth root, any root, you're going to look at your index, and you want the exponent on your variable to be a multiple of that index. Here, 4 is a multiple of 2. And then when you take the square root of a variable raised to an exponent, the way that you're going to do it is your answer is going to be the variable, and then the exponent that you apply is going to be your exponent in the radical divided by your index. So 4 divided by 2 would be 2. So if I take the square root of 4, that would be y squared. And then I can't take the square root of x to the first power or simplify it at all. So this just becomes y squared times the square root of x. Next we have number 4. And for number 4, we're going to follow the steps again. So first step is to divide the coefficients, right? So we're going to do 28 divided by 4, which is 7. And then we're going to divide the radicals, right? This becomes the square root of negative 16m to the sixth power divided by 2m, right? And when you do this expression right here, negative 16 divided by 2 is negative 8, and m to the sixth power divided by m is going to be m to the fifth power, right? So we have, when we simplify, we have 7 times negative 8m to the fifth power. And it's cube root, right? Sorry, so it's 7 times the cube root of negative 8m to the third power, right? Our index is 3 here. So now we need to simplify the cube root of negative 8m to the fifth power. I can take the cube root of negative 8, right? But I cannot take the cube root of m to the fifth power. However, my exponent is greater than my index, so that means that there is something inside of 5 that I can divide by 3, which means I can simplify that, right? So let me break this up into 2 radicals. This radical right here is what I'm going to be able to take the cube root of, and this radical over here is what I can't take the cube root of, right? So I said I can take the cube root of negative 8, so I'm going to put negative 8 here. M to the fifth power, I need to break that up into 2 terms. I need to break up this 5 into 2 numbers that add up to 5. One of them has to be a multiple of 3. The greatest multiple of 3 that I can get from 5 is just 3, right? And then 5 minus 3 is 2, so that means that the other exponent has to be 2. Because if you were to multiply these two together, you would get m to the fifth power, right? This is going to go in the radical that we can simplify. So this is negative 8m to the third power. And this is going to be m squared right here, right? Because this goes in the radical that we can't simplify. Next step is to simplify, right? And we can't also forget about our 7 that we have here, right? So 7 times all this. When we take the square root of negative 8, we would get negative 2, right? And the square root, or sorry, when we take the cube root of negative 8, we get negative 2, right? And then when we take the cube root of m to the third power, we are going to get m, right? So we have 7 times m times the cube root of m squared. So 7 times negative 2 is negative 14m times the cube root of m to the m squared. All right, so hope that one made sense. And I apologize for my voice. I know it sounds a little weird. I lost my voice yesterday at the track meet. But I'm trying my best to get through this. All right, next we have number 5. And if you look at number 5, it's already in this form, right? So if you notice numbers 5, 6, 7, and 8, they're in that form. So that means that unless we can evenly divide A and B in this format, we're going to have to go from this format to this format. And you'll see in a second. For number 5, you're just going to do 48 divided by 16, which is actually 3. So this becomes the square root of 3, right? And we can't take the square root of 3, so that is our final answer, because we can't simplify that either. We can't take the square root of 3, and we can't simplify the square root of 3 any further. It's already in its simplest form. So your answer for number 5 is very simple, just square root of 3. Number 6, if you look at number 6, we cannot take the cube root of, sorry, if you look at number 6, we cannot divide 40 by 27, right? It is not an even number. You would get 1 point something, right? And then we can't take the cube root of 1 point something. So instead, this time we're going to go from this format to this format, right? So we have it all under one radical. We're going to switch it up into 2 radicals. So we're going to change this into the cube root of 40 over the cube root of 27, right? And does everyone understand why I did this? I'm doing this because 27 is a perfect cube. The cube root of 27 is 3. And then the cube root of 40, it can be simplified further, right? We have, we can divide 40 by a perfect cube. The perfect cube that 40 is evenly divisible is 8, right? So this becomes the cube root of 8 times the cube root of 5, right? And we know that the cube root of 8 is 2. So this becomes 2 times the cube root of 5 divided by 3. And this is the final answer, right? We can't simplify any further from there. All right. Hope that one made sense as well. Now for number 7, we're going to be doing the same thing. We need to change this up into the cube, into the cube root of 7x to the 5th power divided by the cube root of 64y to the 6th power. And we're going to do this because look, if we can't divide 7 by 64, but if you think about the cube root of 64, that is a perfect cube, right? So let's change this. Cube root of 7x to the 5th power divided by the cube root of 64y to the 6th power. And I can also take the cube root of y to the 6th power, right? Now, I can't take the cube root of 7, and I can't take the cube root of x to the 5th power. However, I can simplify the cube root of x to the 5th power, right? We're going to break it up into 2 separate exponents. So my numerator, I'm going to separate this. I'm going to first write what I can take the cube root of, which is x to the 3rd power, right? If we're looking at x to the 5th power, I'm breaking it up just like we did earlier. And 2 numbers that add up to 5, and one of them has to be a multiple of 3, right? So 3 and 2. This I can take the cube root of, this I cannot. And this is the same as this, right? So that's why I'm breaking it up this way. And then times what I cannot take the cube root of, which is 7 and x squared, right? And then when you take the cube root of 64, you get 4. And when you take the cube root of y to the 6th power, remember, you divide the exponent by the index. 6 divided by 3 is 2, so you get y squared. And then when we simplify over here, the cube root of x to the third power is just x, right? So we have x times the cube root of 7x squared divided by 4y squared. And that is our final answer. Hope that one made sense again. Again, we went from this form to this form so that we can simplify, because we realize that 64 is a perfect cube. Next we have 32, the fourth root of 32w divided by 81. I can't divide 32 by 81 evenly, so I need to change this into our other form. And now, also, and I realize that because 81 is a perfect fourth, right? However, 32 is not a perfect fourth, but it could be evenly divisible by a perfect fourth. And you can look at the front of your other worksheet that we were working on yesterday, the adding and subtracting, so you can look at the perfect squares, cubes, and fourths that we wrote down. So I'm going to change this to the fourth root of 32w divided by the fourth root of 81. And if you look at this, 32 is not a perfect fourth itself, but it is evenly divisible by the perfect fourth, which is 16. So this numerator is going to become the fourth root of 16 times the fourth root of 2, right? And the fourth root of 81 is 3, so my denominator becomes 3. And then when I further simplify, the fourth root of 16 is 2, so my final answer is going to be 2 times the fourth root of 2, right? Because we can't simplify this. So 2 times the fourth root of 2 divided by 3. That is your final answer. Hope those made sense. Let me know on Monday if you have any questions on any of these. And next, we're going to be rationalizing the denominator. So these examples are going to be very similar. They're going to be the same as this, except the only difference is we're going to have a radical in our denominator. And if you remember back to Algebra 1, you cannot have a radical in your denominator. So we're going to need to rationalize, which means that we're essentially getting rid of the the radical in our denominator. And the way that we're going to do that is we have a couple steps here. So if we have a monomial denominator, meaning that it is just one term, for example, here would be a monomial denominator. You're going to multiply the numerators and the denominators by the radical. So that means that, so I can't simplify this any further, right? So that means that I'm going to multiply this numerator and this denominator by the radical, which is the square root of 5, right? I'm going to read the other case. So if we have a binomial denominator, we're going to multiply the numerator and the denominator by the conjugate, right? And then this tells us that it's the same expression, but with the opposite sign in the middle. We'll see an example of that. And we've done this before. I don't know if you guys remember this. Well, something similar. When we were doing complex numbers, we were getting rid of the i's in the denominator. So the way that we did that is we either multiplied by the term if it was a monomial, and if it was a binomial, we multiplied by the conjugate. So you guys should know what the conjugate is by now, right? All right, so let's start on number 9. For number 9, I can't divide 3 by 2 evenly, so that means that this is already in its simplest form, but we need to rationalize the denominator now, and we need to get rid of that radical. So we're going to multiply 3 times the square root of 5, and then we're going to multiply the denominator by the square root of 5, right? Whenever you multiply, whenever you multiply a number, a radical, two radicals together that have the same radicand and you have the same index, the radical pretty much gets eliminated. I'm gonna start doing that shortcut, but on this first one, I'm just going to show you guys why. So numerator times numerator, we have 3 times the square root of 5, right? That just becomes 3 times the square root of 5. And then we have 2 times the square root of 5 times the square root of 5, right? And if you're following the multiplication steps, coefficient times coefficient, 2 times 1 is 2, right? And then the square root of 5 times the square root of 5 becomes the square root of 5 times 5. And 5 times 5 is 25, right? And then if you take the square root of 25, that is 5, right? So you see what happened there? We multiplied the square root of 5 times the square root of 5. We got the square root of 25. And when we simplified that, we just got 5, which is our radicand, right? So like I said, if you ever multiply two radicals together and the radicand is the same, but also the index is the same, those are the two conditions. If your radicand and your index are the same, the radical just gets eliminated and you're just left with your radicand, right? So now we have 3 times the square root of 5. That can't be simplified any further. Divided by 2 times 5 is 10. And we can't simplify that any further, so this is our final answer. Hope you guys understand that one as well. Next we have 8 divided by the square root of 8 divided by the square root of 15. So I can't simplify that any further, so this becomes the square root of 8 times the square root of, the square root of 8 divided by the square root of 15, right? I can't do anything here, so I need to rationalize my, I need to rationalize my denominator. My denominator is the square root of 15, so I need to multiply the top and the bottom by the square root of 15, right? And again, if we're following the shortcut that I showed you, if you're multiplying the square root of 15 times the square root of 15, you're going to end up with just 15. So we can skip that step. If you wanted to do it, the square root of 15 times the square root of 15 becomes the square root of 225. So check on your calculator if you want to. If the square root of 25 is 15, you'll see that it is. But I guess I'll just write it out. So the square root of 8 times the square root of 15 is going to be the square root of 120, right? 8 times 15 is 120. And then the square root of 15 times the square root of 15 is 225. The square root of 225, right? So square root of 225 is 15, right? And now the square root of 120 can be simplified further, right? So 120 is evenly divisible by 4, which is a perfect square. 4 and 30 are the perfect squares that, 30 is not the perfect square, but those are the two square roots that we're going to change this into. So 4 times the square root of 4 times the square root of 30. And we know that the square root of 4 is 2, so our final answer becomes 2 times the square root of 30 divided by 15. And the square root of 30 can't be simplified any further. That's why we left it that way. So again, I hope that made sense. Again, if you have any questions, just let me know. All right, so we have monomials continuing, right? Binomials don't start until number 15. So I'm confident that you guys can do these on your own. So what I'm going to do is I'm just going to write in the answer for these. Or I can go through it very quickly. Right? So here you're multiplying the square root of 7, right, into the numerator and the denominator. And then you are going to get 7 times 12 is 84. So 3 times the square root of 84 divided by 4 times the square root of 49, which is going to become 7, right? So this is 7. I'm gonna simplify my radical over here, right? So 3 times 84 is not a perfect square, but it's evenly divisible by 4, which is a perfect square. And 84 divided by 4 is 21. So I have 3 times the square root of 4 times the square root of 21 divided by 4 times 7, which is 28, right? Square root of 4 is 2. So I have 3 times 2, which is 6, times the square root of 21, divided by 28. Looks like we're done, but we're not yet. 6 and 28 are both evenly divisible by 2. So our final answer is going to be 3 times the square root of 21, divided by 14, right? 6 divided by 2 is 3, and 28 divided by 2 is 14. So this is our final answer here. Next, we have number 12. So number 12, we're going to rationalize our denominator again. So this is our radical that we need to multiply by, square root of 3a. So when we multiply the square root of 25a to the 5th power times 3a, we're going to get, so it's going to be the square root of 28 times 3 is going to be 72. And a to the 5th power times a is going to be a to the 6th power. And then we're going to take, so this 3a times 3a becomes 9a squared, right? And then next, we excuse me, we're going to have to simplify our numerator. Our numerator, we're going to break it up into, so 72 is evenly divisible by 36, which is a perfect square. So this is going to be the square root of 36. Oh, and we also, so here's what I can simplify, and here's what I cannot simplify. So 36 goes there, 2 goes there. A to the 6th power. Oh wait, a to the 6th power, I can't take the square root of that. So I'm going to go ahead and just write a to the 6th power here. So now I have 36a, index is 2 here, right? And now I'm going to simplify this, right? So now I have 72, or not 72. The square root of 36 is 6. And the square root of a to the 6th power is a to the 3rd power. So I have 6a to the 3rd power times the square root of 2 divided by the square root of 9a squared is 3a, right? And then I can, this are divisible, so we can simplify further, right? 6 divided by 3 is 2. A to the 3rd power divided by a is a squared. And then times the square root of 2. So this is our final answer here. Next we have number 13. So for number 13, this is a little bit different from what we've been doing. It looks the same, right? We're still multiplying. We have a binomial, so we're multiplying by the radical. However, this is, our numerator is a binomial, so we're going to have to distribute this in here, right? So the square root of 2 times the square root of 8 is going to be the square root of 16. And then the square root of 2 times the square root of 2 is going to be square root of 4, right? And then we have a minus in between them, so that's why I wrote the minus there. And then the square root of 2 times the square root of 2 is the square root of 4, right? So the square root of 16 is 4. Square root of 4 is 2. Square root of 4 is 2, right? So this becomes 4 minus 2 divided by 2. 4 minus 2 is 2. And 2 divided by 2 is 1. So our final answer is 1 here. Number 14, again, we have a monomial denominator. So we're multiplying by the square root of 12, square root of 12. So we're going to distribute, again, this is one term, right? One binomial term. So we're going to multiply square root of 12 into here. So 3 times the square root of 12 is going to be 3 times the square root of 24, right? 3 times the square root of 2 times the square root of 12 is 3 times the square root of 24. Next we have square root of 6 times the square root of 12, so plus square root of 72 divided by square root of 12 times square root of 12 is square root of 144. Now I need to simplify these, right? So square root of 24, I'm going to break that up into, I'm going to write it over here. So 3 times, so the square root of 24, here I'm going to circle it in blue so I can show you guys what I'm writing. So the square root of 24, I'm going to break it up into the square root of 4 times the square root of 6, right? 4 is a perfect square. Next, I need to break up the square root of 72, and I'm going to break that up into, let's see. So square root of 72, I'm going to break it up into the square root of 36 times the square root of 2. Right, 36 is my perfect square. And then this is being divided by square root of 144 is 12, right? So you guys have been seeing that when you're multiplying a radical by a radical and they have the same radicand and the same index, you're going to end up with just the radicand, right? All right, so now let's go ahead and simplify. The square root of 4 is 2. Square root of 36 is 6. So I have 3 times 2 times 6, which is 36. And actually, sorry, we can't do that because of this plus sign right here. This is plus this, right? So we're actually doing 3 times 2, right? So we have 3 times 2, which is 6. 3 times 2 is 6, times the square root of 6. So we have 6 times the square root of 6 plus 6 times the square root of 2, right here, divided by 12. And these 3 coefficients are evenly divisible by 6. So here 6 divided by 6 is 1. So this becomes the square root of 6 plus the square root of 2, right? This is divided by 6 and it's 1. And then 12 divided by 6 is 2. So we have the square root of 6 plus the square root of 2 divided by 2. All right, number 15. Now we have a binomial, right? So we are going to rationalize the denominator again, except this time we are going to be multiplying by the conjugate. So I need to multiply by the conjugate of 4 plus the square root of 2. And the conjugate, again, it's going to be the same term, except this changes to minus, right? So the conjugate of 4 plus the square root of 2 is 4 minus the square root of 2, right? So we know that we need to multiply the numerator and the denominator by 4 minus the square root of 2. All right, so when we distribute 4 in here, right, we have 4 times 4, which is 16. And then minus 4 times the square root of 2, right? So this is a minus right here. Divided by 4 times 4 is 16. 4 times square root of 2 is, and it's negative, right? So minus 4 times the square root of 2. Then we distribute the square root of 2 into here, right? Oh, let me erase this real quick. So now we're distributing the square root of 2, right? So square root of 2 times positive 4 is plus 4 times the square root of 2. And then square root of 2 times negative square root of 2 is going to give us negative square root of 4. All right, so if you see this, these cancel out. That's why we want to multiply by the conjugate, because when you multiply by the conjugate here, it's going to eliminate each other out, right? So this gets eliminated because we have a common radical, right? Our common radical of square root of 2. And so we combine the coefficients. So negative 4 plus 4 is 0. That's why these get canceled out. So we are just left with 16 minus the square root of 4. The square root of 4 is 2, right? So we're left with 6 minus 2, which is 7. And then, so we have 16. Oh, sorry, 16 minus 2 is 4, not 7. So we have 16 minus 4 times the square root of 2, right? Our numerator. And then 16 minus 2 is 14. I'm thinking way ahead. So the numbers, the 3 coefficients we have here are all evenly divisible by 2, right? So 16 divided by 2 is 8. Minus 4 divided by 2 is 2 times the square root of 2. And then 14 divided by 2 is 7. So that's our final answer. All right, hope that one made sense. I'm going to go through this next example again. I'm going to go through this one slowly so that you guys can, again, see what we're doing here. So for number 16, we have a binomial denominator with a radical. We need to rationalize our denominator, meaning we can't have a radical in there. So we're going to multiply by the conjugate of 6 minus the square root of 5. And remember the conjugate, this just changes. So the conjugate is going to be 6 plus the square root of 5. Right. So let's go ahead and get started here. Let me erase this right here real quick so I can have space to show the arrows. I'm going to put parentheses around this. All right, so first we're distributing 2, right? So 2 times 6 is 12. 2 times the square root of 5 is plus plus 2 times the square root of 5, right? Next, we're going to distribute our denominator, right? So I'm going to try to go slowly here. And I'm going to use different colored pen, right, so that we can see what we're doing. So first we have 6 times 6, which is 36. Oh, wait, hold on. So 6 times 6 is 36. And then we have 6 times the square root of 5, which is just going to be plus 6 times the square root of 5, right? I'm going to do the next in red. So now we're multiplying negative square root of 5. So negative square root of 5 times 6 is negative 6 square root of 5. And then negative square root of 5 times positive square root of 5 becomes minus square root of 25, right? So next we're going to simplify this, right? So here we have common denominators, right? They end up eliminating each other, right? Because we have this common denominator, so we combine the coefficients. 6 minus 6 is 0, so these get canceled out. We can't simplify anything in our numerator, and then we know that the square root of 25 is 5, right? So our final answer is going to be 12 plus 2 times the square root of 5. That's our numerator. It doesn't change. Can't simplify anything there. And then we have 36 minus 5, which is 31. That is our final answer here. So again, hope that makes sense. These are going to start getting a little more complicated. We only have 4 more left. So let me erase that here so I can write here. So number 17. Again, we have a binomial denominator with a radical, so we need to rationalize the denominator by multiplying by the conjugate. So the conjugate is this is just going to change. Everything else stays the same. So all right, so we're going to distribute this square root of 3. So square root of 3 times 1 is square root of 3. Square root of 3 times 4 times the square root of square root of 3 times negative 4 times the square root of 2 is going to be negative 4 times the square root of 6. And then for my denominator, again, I'm going to do different pen color. So we have 1 times 1, which is just 1. 1 times negative square root of 4 is going to be negative 4 times square root of 2 is negative 4 times the square root of 2, right? Next, we're going to distribute negative 4 times the square root of 2. Negative 4 times square root of 2 is, and sorry, I didn't do the conjugate. This is supposed to be plus, right? Sorry about that. The conjugate of 1 minus 4 times the square root of 2 is 1 plus 4 times the square root of 2. So here we have, the only thing that's going to change here is this in our numerator is that that's going to be positive, right? So sorry about that. Let's get started again with the denominator. So 1 times 1 is still 1, right? And then 1 times positive 4 times the square root of 2 is plus 4 times the square root of 2. And then next we have negative 4 times the square root of 2, which is negative 4 times the square root of 2. Right? And then we have negative 4 times the square root of 2 times positive 4 times the square root of 2. Coefficient times coefficient. Negative times a positive is a negative. 4 times 4 is 16. And the square root of 2 times the square root of 2 is the square root of 4. So this is our expression after we distribute our conjugate. All right. So in the numerator, I can't simplify anything, right? And in my denominator, we have a common radical. Again, that's going to happen every time when you multiply by the conjugate. These are going to eliminate each other out. Square root of 4, we know that is 2, right? So this becomes 16 times 2. Or, yeah, 16 times 2 is going to be, and can't forget about the negative, that is going to be negative 32, right? So we have square root of 3 plus 4 times the square root of 6. And then 1 minus 32 is going to be negative 31, right? So this is our final answer because we can't simplify anything else. All right? So don't make this mistake that I made in the beginning by not multiplying by the conjugate. It can happen easily. So make sure that you don't do that. All right. Number 18. Number 18, we're going to multiply by the conjugate of our denominator, right? We have to rationalize our denominator. And the conjugate of our denominator is going to be the same except negative, right? So I won't make that mistake again. So negative 5 minus the square root of 3. So square root of 5 minus the square root of 3 is our conjugate. Square root of 5 minus square root of 3. All right, so again, we're going to distribute first, right? So let's start off with our numerator, and I'm going to do different colored pens in the numerator as well. So we have 5 times the square root of 5, which just becomes 5 times the square root of 5, right? Next, we have 5 times negative square root of 3. So that becomes negative 5 times the square root of 3. Right? So now we're going to distribute negative square root of 5. Negative square root of 5 times negative square root of, times positive square root of 5 becomes negative square root of 5 times 5 is 25, right? Next, we have negative square root of 5 times negative square root of 3. Negative times a negative is a positive, and it becomes square root 5 times 3. 5 times 3 is square root of 15, right? So I hope everyone follow along so far for that part. Next, we have our denominators. So square root of 5 times square root of 5 becomes square root of, sorry about that, erase. Square root of 5 times square root of 5 becomes square root of 25. Square root of 5 times negative square root of 3 becomes negative square root of 15. And then positive square root of 3 times, let me change the pen color, positive square root of 3 times positive square root of 5 becomes positive square root of 15. And then the square root of 3 times negative square root of 3 becomes minus square root of 9. All right, so let's go ahead and simplify this. So in our denominator, we know that the square root of 25 is 5, right? And let's see, can we simplify anything else? So we have minus 5. So we can't simplify anything in our numerator after this, right? So what we're going to do is we're going to simplify our denominator. So again, we have common radicants, and they cancel each other out, right? So that becomes nothing. The square root of 25 becomes 5, and the square root of 9, so this becomes minus 3, right? The square root of 9 is 3. So our final answer is going to be, you can write this in any order you want, right? It doesn't matter as long as you have the correct sign supplied, but I'm going to write it in the order that I got it, my numerator. So I have 5 times the square root of 5 minus 5 times the square root of 3 minus 5 plus square root of 15 divided by 5 minus 3 is 2, right? So this is your final answer. It's really long. All right, let's go on to number 19. So number 19, again, we're rationalizing the denominator. So we're going to multiply by the conjugate. Won't make that mistake I made earlier. So this is 3 minus, so the conjugate here, right? we have 2 minus 2 times the square root of 7, right? So 2 minus 2 times the square root of 7. And let's go ahead and start simplifying, right? So let's start by distributing our numerator. So we have 3 times 2, which is 6. We have 3 times negative 2 times the square root of 7. 3 times negative 2 is negative 6 times the square root of 7. Now we have the square root of 7 times 2, which is going to be plus 2 times the square root of 7. And the square root of 7 times negative 2 times the square root of 7. So that's going to be negative 2. And then the square root of 7 times 7 is 49, so square root of 49. All right, let's distribute our denominator. So 2 times 2 is 4. And then we have 2 times negative square root of, negative 2 times the square root of 7, which is, so 2 times negative 2 is negative 4. And square root of 7. Next, let me change the pen color. Next we have 2 times the square root of 7 times 2. 2 times 2 is positive 4 times the square root of 7, right? You already see that these are going to cancel each other out. And then 2 times the square root of 7 times negative 2 times the square root of 7 is negative 4, right? And times the square root of 49. So let's go ahead and simplify these. All right. So I can't simplify anything here, right? I can simplify this, though. The square root of 49 is 7. So I have negative 2 times 7, which is negative 14, right? All right, so that's what's simplified in my numerator. I can actually combine those as well, right? We have a like radical. So let's go ahead and combine like terms now. So 6 minus 14, those are two like terms, right? 6 minus 14 is negative 8. Same radical, right? Common radical. So then we have negative 6 plus 2, which is going to be minus 4 times the square root of 7, right? And then let's simplify our denominator. So these are going to cancel each other out, right? Like radical, and we're going to combine the coefficients. Negative 4 plus 4 is 0, so they cancel each other out. The square root of 49 here is going to be 7. So we have 4 times 7. 4 times 7 is 28. So we have minus 28 over here. So we're going to combine those like terms now. 4 minus 28 is negative 24. And then these three are evenly divisible by 4, right? So negative 8 divided by 4 is going to be negative 2. Negative 4 divided by 4 is going to be just negative 1. So minus the square root of 7. And then negative 24 divided by 4 is going to be negative 6. And you can actually turn those into positives, right? So divide each by negative 1, right? So it's going to be 2 plus the square root of 7 divided by 6. You just change the signs, right? Since they're all negative, you can change them all to positive. All right. So hopefully that one made sense as well. And then finally, our last one. So we're going to multiply by the conjugate of our denominator, which is 3 plus 4 times the square root of 6. Right? All right. So let's go ahead and distribute. So we have 8 times 3, which is 24. Then we have 8 times 4 times the square root of 8. So 8 times 4 is 32. So this is plus 32 times the square root of 6, right? Next, I'm distributing minus the square root of 6. So minus the square root of 6 times 3 is going to be negative, or minus 3 times the square root of 6, right? And then minus square root of 6 times 4 times the square root of 6 is going to be giving us minus 4 times the square root of 36, right? All right. Next, let's multiply our denominators. So we have 3 times 3, which is 9. We have 3 times 4 times the square root of 6. 3 times 4 is 12, so this is plus 12 times the square root of 6. Next, I have minus 4 times the square root of 6 being multiplied by 3. 3 times negative 4 is negative 12 times the square root of, and it's actually 36, right? Oh, wait, no, sorry. It's just 6. These two are like terms, right? So they're going to end up canceling each other out. Next, I have negative 4 times the square root of 6 being multiplied into 4 times the square root of 6. So coefficients first, negative 4 times 4 is negative 16. And then negative square root of 6 times the square root of 6 is going to be the square root of 36, right? So we can go ahead and simplify our numerator first. So if you look at these two terms right here, they have a like radicand, right? So let me go ahead and write my line right here. All right, so let me actually write it over here. So I'm just going to write 24 down, right? So 24. And then I have 32 times the square root of 6 minus 3 times the square root of 6. Since they share a common radical, we can combine the coefficients. And 32 minus 3 is plus 29 times the square root of 6. Over here I have the square root of 36 is 6. So negative 4 times 6 is going to give us negative 24, right? And then if we simplify our denominator, I'm going to write my 9 over here, right? These have like a common radical, and they're going to end up canceling each other out, right? So then I'm just left with negative 16 times the square root of 36 is 6, right? So negative 16 times 6 is negative 96. Right, so let's go ahead and simplify now, right? We can combine these two like terms, right? 24 minus 24 cancels out, right? So in our numerator, we are left with 29 times the square root of 6. And then 9 minus 96 is negative 87. I don't know if you guys know this, but 29 and 87 share a common factor, which is 29. Yep, 29 divided by 29 is just 1. So our final answer is going to be the square root of 6. And then negative 87 divided by 29 is negative 3. So our final answer is the square root of 6 minus 3. So hopefully this helped you guys out in this classwork. Please let me know if something didn't make sense so I can help you guys out. We have a quiz on Tuesday, so make sure that you work on your quiz study guide. We're going to be working on Monday, we're going to be working on a study guide the whole day, or the whole class, I mean. So, but make sure that you work on it over the weekend so that you can be prepared for that.